Do you want to squeeze some performance out of your Python AWS Lambdas for free? Coming up. Hi, I'm Rafael, and this is Coder Cave. Today, we will boost the performance of a Python AWS Lambda by just changing the target runtime. Here is the code. This is our Lambda handler. It receives a document as part of the payload of the request through the post endpoint. It computes a SHA-256 and then returns the digest as part of the response. This code is deployed twice, so with two lambdas. The first lambda is called hashme37, runs on a Python 3.7 runtime, and is accessible at /hashme37 post endpoint through API gateway. The code is also provisioned with hashme38, which is another lambda. It runs exactly the same code, but on a Python 3.8 runtime, and it's accessible at /hashme38 post endpoint. So with that, we are ready to deploy. And while the deployment is progressing, I want to give a big shout out to Alexander, who created the banner and the avatar for this channel. I found Alexander on Fiverr.com, the place where you can hire all sorts of professionals for gigs ranging from graphic design, video editing, business consultation, software development, and many more. If you want 20% off of your first Fiverr.com order, please make sure you use the link in the description. And if you need art for your YouTube channel, make sure you check out Alexander's gigs. Alright, now the deployment was successful. Now it's time to go to API Gateway and find the URI for our API. So we will find the URI in stages. I will get the production deployment and I will look for the post endpoint for the 3.7 deployment. So I will use this URI, and now I will be using jmeter to create a very simple load test. So jmeter, you will need Java installed to use jmeter. I will create a thread group. I will call this 3.7, so I remember that this one is the Python 3.7, and I will create a sampler, HTTP request sampler. I will call also this one 3.7. So a sampler is a component that basically creates HTTP calls. So I will say it's an HTTPS, and I will need to move the actual path over here. Now I need to give it a payload, and the payload is a very simple JSON document with a property called document with some random text inside. And with this, I should be able to hit the endpoint, but I need also another thread group for the 3.8 version of our endpoint. So again, another HTTP request sampler. I could group the two request sampler in the same thread group, but I want them to be as isolated as possible. So again, it's a post endpoint, and for that I will need to go back to the AWS console to find the exact URI. It's probably the same, very similar to the one I already deployed, but I don't want to take any chance. So here we are back to jmeter. Yep, that's the wrong place. hashme38 is our path, and I have to specify HTTPS as a protocol, and I will just copy the payload from our previous sampler, just to have everything exactly the same. Now in the test plan, I also want a listener, which is a summary report. So with this, I will see the results of my test. So let's run the test. All right. So here we see that we don't have errors, 0% error rate. And we see that for one request, we have a fairly similar execution average time. Well, average. We only requested once. So we see that 3.8 is slightly faster, nothing exciting. So let's create a barrage of requests. Let's say we'll send 100 concurrent users and we will ramp them up in 5 seconds. I will do the same for the 3.8. Obviously, I want consistency here. Okay, the report has already been erased. Let's run it again and let's see what the average execution will be for the comparisons of frameworks. All right, so here we see that there is a slight difference. It is nothing crazy, but still the framework 3.8 is performing slightly better than 3.7. This Lambda was way too simple. Let's add some complexity to see if the result changes. I want to pull a file from S3, so for that I will import bota3, which is the library for Python that interfaces with AWS services. So I will list also this as a requirement. And I already have some snippets for the code I want to use. So I will paste this pull and hash. So pull and hash is going to get the file from S3, hash it again with Shoutout56, and return the digest. And this is going to be returned to the caller by means of this code here. So we just call pull and hash and add the digest in the request. Now, because we need to access an S3 bucket, we need to give our lambdas the permission to access this S3 bucket. And we do that by adding a policy. So we'll add the policy down here, bucket access, and now I also have to say to give the policies to the lambdas. Both lambdas. So hashme38 is ready, and now this is hashme37. So with that, we should be good to go to deploy. One thing that I forgot to mention is that I converted the endpoints from post to get. All right, let's go back to jmeter. I already updated those HTTP request samplers so that they are now get requests without any body payload. So let's run those tests. Those tests are going to take slightly longer than the first ones, actually a lot longer, in the couple seconds. And we can see that again 3.8 is performing slightly better than 3.7. We can run this test once more to see that this is happening consistently. It's not a dramatic change, but it is there. Let's add some more complexity. Let's say that we want to provision a couple of APIs with Flask using Zappa. We are going to code, we'll first need to import Flask. So from Flask, we'll need to import Flask and then create an application. Watch out for the typos. All right, so we have our application, and now I will get the code for the endpoint. And the code for the endpoint is very simple. It's basically the same thing as the Lambda handler. So it's going to do a digest, gets a digest using the pull and hash and returns that in the payload. And this annotation here defines the endpoint hash me. All right, so with that, I will add Zappa and Flask as requirements. And then what we need to do is to actually install Zappa on our virtual environment. So I created a virtual environment. I already activated that. So I need to obviously install Flask, and then I will also need to install Zappa. Alright, Zappa is installed. I don't want to use the wizard to create a Zappa settings file, so I want to create it by myself. So I need to create a Zappa settings.json, and then I will add some settings that I already have prepared. So I will create a couple APIs, one called 3.7 that uses Python 3.7, and the other one is 3.8, and obviously it uses Python 3.8. and they both point to source app application. So exactly the same code. Now that Zappa is installed and we have our settings, we can do a deploy. And we'll deploy 3.7 first. Now, at the end of the deployment, Zappa is going to tell us the exact endpoint for this API. All right, we have our 3.7 deployed. Let's deploy also 3.8. In the meantime, I will grab this URI over here, and I will need it for jmeter. So let's update our jmeter load test. So let's go back into our 3.7 request, copy or paste the endpoint, and the endpoint is called #me, not #me37. Okay, so now the deployment of 3.8 should be completed. Let's go back. I need to grab again this endpoint. We go back to jmeter, grab the correct sampler, and update a few things. And now we should be ready to test. So let's clean our report and let's run a test. All right, results are coming in. We have a 0% error rate, and we see that it's taking quite a while for those responses to come back. And we see that the change in execution time is dramatic. Now those numbers look a bit off, so let's try again. Let's run the whole test once more. Sure enough, now the execution time is much shorter, but the difference between framework 3.8 and 3.7 is much larger than in our previous examples. Alright, so we can see a difference in performance. It's not dramatic, but it is there. But why is this happening? We are not using specific features of Python 3.8. As a matter of fact, we just changed the runtime. We didn't change code whatsoever. Well, the reason why this is happening is because when we declare the runtime as Python 3.8, our code is running on a new virtual machine by Amazon Linux 2, whereas Python 3.7 runs on an older image called Amazon Linux. And because Amazon Linux 2 is a lighter VM, we can see that there is some performance gain. So here it is, a quick and easy trick to squeeze a little bit of performance out of your Python Lambdas. Now let me know in the comments, what are your tricks to squeeze even more performance out of your Lambdas? Subscribe to the channel and check out the repos at github.com/codercave.